right, so how's everybody doing today? So first of all, I'm going to do another open lab tomorrow. So no new material, no lecture tomorrow, but come in, work on your code, share your screen with me, and so on and so forth. I'm starting to get a few people coming to office hours, which is nice because I'm doing like 8 office hours a week, and mostly I'm just sitting here doing work, which is fine. But it's a good chance to come in, talk about questions with assignments and stuff. All right, so I posted PA1 grades and some comments. Most people either got 100 or, they put in their comments I couldn't get toString to work, and so they lost points for toString and so on and so forth. The only possible surprise for people was losing points for that section on commenting and style, and that's 20 points, right? And I'm gonna stick to deductions for that, right? Because I really want people to leave this course and this program with a solid programming style and good commenting habits. So, for example, put your name into your class description, right? Anything you turn in that you've written, make sure you put your name on it. Okay, so that's one thing. And when you write a class, right, describe the class in the beginning. Put something in there, and don't just say even class or indexer class, right? What does this class do? This is where you are documenting it. This is a class that is used to build a word index. You give it a file, and it will open it up and read in words and store them, etc., right? And then every method in the beginning of the method, right, usually right before the declaration of the method, have a block saying, this is the number of words method that goes through the index and tells you how many unique words you have stored in it, right? This is where you can also say, if the index has not been built, this returns -1, right? So that's the synopsis of the function. Take a look at the Java documentation for any class you like, and see what kinds of information are in there, right? There's something in the beginning that talks about the class. There's a section that talks about the constructor. There's a section that talks about each method. You're putting that information into the code itself, okay? Style-wise, spacing, indenting, I'm really satisfied with that, right? People are doing a really good job of indenting based on how deeply you're nested, and that's really good. So keep that up. There were a few cases where people had comments kind of all over the place. They tried to line them up, I think, but I think they were using a different editor and using tabs instead of spaces, but the tabs were set differently. Take a look at your code on the server, okay? That's where I'm going to be looking at it. Make sure it looks the way you want. If it doesn't, right, and do this before you're ready to turn it in. If it doesn't look the way you want, figure out how to adjust whatever editor you're using to make things come out the way you want, so things are lined up and so on and so forth. If you're using a editor like Notepad or something, make sure you use a fixed space font like Courier. If you use proportional spacing, you'll line it up in Notepad, but it won't look good when you actually look at it in VI. Easiest approach though, just use VI, right? It will make you faster down the road. So anyway, those are my only comments after turning in the grades for PA1. So any questions or concerns about that, go ahead and shoot a note and let me know. Otherwise, just continue the way you've been doing, modulo those comments. All right, and any questions on PA2 so far? All right. So let's play with Hashmaps today, because that's sort of the central piece of PA2, and there's a lot going on. So I'm going to combine some of the stuff we did with scanners with Hashmaps, and so let's just write some code. So I won't worry about files, but it will have Hashmaps. right, so we'll open a scanner to read from standard in. And what should we do? Let's make a hash map. And I'm going to make a hash map of words. Okay, so we're going to have a pair of things in our map. Hold on, let me focus. We're going to have, a key data pair. And let's just set up key to be a word. And let's set up data to be another word. Okay, just to get the ball rolling. So we'll hash a pair of words. So I'm going to read this in one line at a time. And let's break our input into let's see, how do I want to do this? Let's break our input into words. Okay, so let's make a pair of commands. So I'm going to let the user say either put and then list the key and then list the data, or I'm going to let the user say get and put in a key, and it should retrieve the data that we stored with that key. Okay, so a pretty straightforward 224 style user interface. Two commands, put key data or get key, and it should retrieve the data. So if we're storing, say classes that people are taking, I can put Nick 223, I can put Tina 109, and so on, and then I can say get and put in a name, and it'll tell me what course that person's taking. Okay, so this is just to play around. So we're going to take a line from the user. So command, let's call it input equals sc.nextLine. So you can either say put, let me call this key. You can either say put a key in some data or get a key. Okay, so we have an input. It's got either 3 things on it or 2 things on it. They're separated by spaces. Let's go ahead and use split. Okay, we played with split yesterday. Let's split this in 2 words. So string words equals input dot split around a space. All right, so we need to now say, what did the person ask us to do? If they said let's put a key, we're going to go ahead and do something to store into our hash map. If they said get a key, we're going to do something to read from the hash map. If they said anything else, we're going to yell at them and say, hey, say either put or get. All right, so I'm just going to do that as a series of cases. I'm not going to use a case or a switch statement. I'm just going to write this out as if statements. So is this put command. So how do we tell if they said put? Well, we have to look at the first word that they input, okay, which was words bracket 0. And we want to know if that's equal to, quote, put, okay? So don't do this, because equal equal tells you if 2 things are exactly the same, not whether the thing that they're pointing to contains the same letters, okay? Same thing we saw in C. So instead of equal equal, we need something like string compare. In Java, strings have a method for comparing things. It's called dot equals. And so we can say if word bracket 0 dot equals put. All right, this returns a Boolean value, so we can just end our if statement here, or we could say if this thing equals true, right? But that's redundant. Because if this thing equals true, we could just have said this. And if it does not equal true, we could have just have said this. So if words bracket 0 dot equals put, save the data in the hash. All right, and we'll add that in later. Else if words bracket 0 dot equals get, retrieve the word from the hash. Else and we'll give them a little hint about what to use. Either say get key or put key data. And that's the end of our loop. All right, well, let's prompt them, right? Let's not just drop them into a program that's waiting for input. Let's give them a prompt. And I don't want a new line at the end, so I'm just going to use print instead of print line. And at the end of my loop, I'm going to prompt them again before I go back up. And then after we get out of that loop, we'll say goodbye. And that's the end of our main program. And let's throw some debugs in here. All right, so what are we doing here? We're writing the kind of outermost shell of this method, right? This main program. We're parsing the input. So we're reading in a line of input, we're splitting it into words, we're seeing if the first word is put, or get, or neither, and we're responding accordingly. Okay, so this is a place where I would start working with the code, compiling it, running it, make sure it works. Because what comes next is we're going to put stuff in here that actually interacts with the hash map. And that's the more challenging part. That's the part that's fundamentally new, right? Even though scanners and strings are somewhat new to us. That's the part we're really working on today is interacting with a hash map. So let's take this at this point and let's compile it. Hey, not bad, only one. I forgot my parentheses on next line. Right, so has next line is a method. And now I can run this and I can say put data word, and it says I'm putting. I can say put haha, ha ha ha. I can say get haha. I can say get out. I can say meaningless stuff, and it tells me it's an error. Use a getter or put. And if I just hit enter, it sees an empty string, and so it says use a getter or put. And then when I control D, it says thanks for playing. All right, and I can see a few things in here. When I do that exit message that says thanks for playing, I should probably put a new line in the beginning of that. And other than that, we're good to go. Okay, so let's put some things into our hash. All right, so save the data in the hash. So the way we split this, this was bracket 0, this was bracket 1, this was bracket 2. All right. So our hash is called data, and it has a put method, and put takes a pair of arguments, basically the word that you want to use, or the thing that you want to use for the key. So that's words bracket 1, and the thing that you want to associate it with it, which is words bracket 2. That's really all there is to it. That's going to store our data into the hash. And when we want to retrieve a word, all we have to do is data.get and give it the key that we want, which is, you know, words bracket 1. So we've got a little database program here, right? We can store things, we can retrieve things. Now, when I do this, I need to specify what kind of data I want my hash to have. I don't know what it'll do if I try to run it like this. Should give me lots of errors. Unchecked or unsafe operations. I like that. This will probably, I hope this will blow up. So put data 2, get data. Oh, it worked. Shouldn't have worked. Okay. So anyway, let's be careful here, right? So remember, when we use a hash map, we have to specify what kind of key and what kind of data it's going to use. So let's be explicit and say we want a pair of strings. Okay. And that's what the unsafe operation is, was that I wasn't explicitly specifying that. I was hoping it would blow up gloriously. But anyway, so when you make a hash map, right, if you want your key and your data to both be strings, you set it up like that. All right, well, there's a hash program now. Let me just change this to a print line. All right, so compile this up and run it. So let's put, I don't know, I'll just put in parts of speech. So cat is a noun. Let's put dog is a noun. Let's put run is a verb. Let's put fast is an adjective. And let's put quickly is an adverb. I don't know my parts of speech. Okay, and so now I can say, what is a dog? It's a noun. What is a run? It's a verb. What is ha-ha? It's null. Didn't find it. Right, so it wasn't in there. So in my code, I could say, you know, try to get this thing, and if it's null, print out a message saying this thing isn't found. All right, so there's a hash, right? We're storing things in, we're retrieving them based on a key. And that's effectively what you're going to do for PA2. So let's Control D. Thanks for playing. Goodbye. The only difference is in PA2, the type of data you're associating with a key is actually a linked list. So let's go ahead and play with that. So we'll store a linked list. And for PA2, it's going to be a linked list of integers. I'm going to make a linked list of strings, because I don't want to do exactly what you're going to be doing. So we're going to have a hash map whose key values are strings and whose data values are linked lists of strings. Okay, heck of a lot going on in this one line here. Right, declaration of a variable, specification of types for two different classes, and then construction of an object. And this little variable data is now a real powerhouse, right? it has all the methods available in a hash map. And anytime you do something like data.get, the value that it returns has all the methods of a linked list, because the value that's stored is actually a linked list. All right, so let's enter a command. So let me change my interface now. Let me put this back the way it was. And let me switch to main 2. Alright, so I'm going to change the interface here. We're going to do one of the following 2 things. I'm going to say put. It's going to ask me for the word that I want to put, and I'll type in the word. And then it's going to ask me for some information about that word. Okay, some things that I want to say about it, and I'm going to put in 1 or more lines of information, and I'm going to end with an empty line. And each thing that I say about this word is going to get stored in a linked list. Okay, so this is just kind of a goofy example here. So I'm going to be able to say put cat, and then it's going to ask me for information about the cat, and I can say it's furry, and it likes milk, and it lands on its feet. And then I'm just going to hit the enter key to say I'm done telling you about a cat. And then it's going to ask me for a new command. And I can say put dog, and so on and so forth. And then I can say get, and it'll ask me what I want to get information on, and I can say get information on a cat, and it will go through the linked list, tell me how many things it knows about a cat, and then tell me each of those things one by one. Okay. So this is just adding things into a linked list associated with a word, and then pulling things out of that linked list by going in with the word and doing a get. Alright, so again, it's not PA2, but it's a similar process, a very similar process. Okay, so let the user say prompt, say put or get. So we'll read a line from the user, and we won't bother splitting it into words here. So is this a put command? So if words bracket 0 equals put, save the data in the hash. Okay, so I'm going to make a method for this. So let's say if they want to put, let's save information keyed off of words bracket 0, right? And let's save it into let's save it into our data. Otherwise, if the word they put in was get, let's show information from that hash map. Otherwise, we'll say legal commands are get input. Alright, hope everybody's still with me here. So let's make some methods. So let's get info from the user and save it in the hash map. So this is going to be void save info, and it's going to be a string key and a hash map. hash map of that type that I'm just going to call, I'll just call it hash. And then retrieve info from the hash is going to be show info, and again we take in a key and a hash map, and we'll show information to the user. All right. If I try to compile this, I'm going to get annoying messages. Oh, well, that's the first thing. I need a linked list. All right, so include Java U linked list. Those aren't the annoying messages I was expecting, though. So line 19, words bracket 0. So if you're in VI, right, you can just say 19 and hit an uppercase G, and it brings you right down to line 19. All right, so I'm reusing my previous code, but I'm not splitting my string. So this should just be input. So that was just typo. So input is my string, and I will pass it to my functions. And so here's the annoying error message that I was expecting. Non-static method save info cannot be referenced from a static context. Okay. So I'm being sloppy here, right? I am writing all of this action inside my main method, and my main method is defined to be static. Okay. We're still not ready to talk about what exactly static means, but if you're writing main methods that your main program are going to call, you're going to get that error, and the only way to fix that is to make these methods save info and show info static. Okay. But if you're defining a class, right, like indexer, you should not have to have any statics in there. Okay, so I'm using statics in here, but you should not have to, right? Because you're not writing a main program, and the main program is different. The main program is static because that's how the system knows to run it. So we'll deal with statics another time. But if you're doing this in indexer, you won't get this message about these things needing to be static. So don't use the word static here in your indexer class. But we'll use it here and it'll compile. Okay. So let's play with our linked list. So we want to save info. All right. So construct an empty linked list to be associated with what did I call it? Key. All right. All right, so there's a linked list. This is what I'm going to store into my hash map along with key. Okay. I'm just going to stick to my comments over here. So get words from the user. All right. So I don't want to get too tangled up in logistics of string processing here. Basically, I want to read in. Now let's just use split. We'll make it easy. Okay, so nope, I am going to get tangled up in them. Okay. So tell me some things about this word. And when you're done, just hit enter on an empty line. Okay, so string description equals, I'm going to have to pass the scanner object also. So let's read the next line. So we'll read a line from the user, and while the input was not empty, right, while the length of that line was bigger than 0, let's just add what the user typed in to the end of our linked list. So ll.add description. And then let's read the next line. And so we're going to loop here, right? We're going to keep asking the user to type in a piece of information. We're going to ask them to keep typing in pieces of information, and as long as they type something, we will take what they typed and add it to our linked list. So get a line of input from the user. If its length is bigger than 0, add it to our linked list. And when the user just hits an empty line, they're done typing in their description. Our linked list is done. Let's store our linked list into our hash map. So our hash map is called hash, and let's say hash.put, and we're going to use the key that the person typed in, and we're going to store this linked list, which is called LL. And then we're basically done. So we can just return at that point. Okay, since I'm doing input from here, I need to have the scanner. So I'll pass the scanner as well, and I'll pass SC when I call it. All right, so our save info should be all set. Let's compile that and make sure we didn't do anything systematic. Okay, so that works. Let's write the show info. So show info, the person said get, so let's pass the scanner to that. We're going to ask them what they want information on. So show info. Alright, so ask user what they want information on. So enter something you want to know about. And we'll do word equals sc.nextLine. And then let's just pull that out from our hash map. So let's make another linked list again. So linked list LL equals new linked list. Well, it's not going to be a new linked list. It's going to be our hash.get. And what do we get from? We get using the key. Okay, so LL is our linked list associated with that key that we're retrieving from. So did we find something? If the linked list that came back, if the piece of data that came back was null, then that key was not stored in our hash. So we'll say I don't know anything about whatever the key was that they asked, and we'll return. Otherwise, we'll tell them some information about their item. So we can say I know ll.size things about whatever they asked us for information on. So I know this many things about key. And then let's go through the linked list and give them back their information. So we'll iterate. So we're just iterating over the items. So fact number, and we'll tell them the index we're about to use, and then we'll say get item I from our linked list. And then we'll just print an empty line at the end, and we're ready to go back. All right, so the reason we're doing this, right, I want you to see, you know, the idea of building this up in pieces, and I've got a lot of code here, but I don't need to go back and look at anything above this page right now, right? Show info is a standalone function. It's got a scanner coming in, it's got a word that I want information on, and it's got a hash map called hash. And all of this stuff, all I need to know is what a hash map is, what a linked list is, right? And how I got this key, where the scanner came from, makes no difference to me, right? When I want to get information, I just call sc next line. When I want to pull my linked list out of my hash, I just use the get method. And when I want to interact with the linked list, I can use the size method to see how many things are in there. I can use get to get an item, and I can tell if it's null by just seeing if it's null. So this is modularization. Yes, this code will definitely be posted on Canvas. But the code itself is not terribly beneficial, right? I mean, it's useful, but I want you to think more about the process of how this code came to be. Okay. We should see if it works before I say any of that. Well, it compiles at least, right? So let's go ahead and run it. Let's call it the right thing. I'll put public in there. Okay, so let's compile it. Let's go ahead and run it. So enter a command. So let's put some information in. Well, I messed up. Enter command put. Tell me some things about put. Oh, I forgot to ask what they wanted to put information about. All right, so save info. So what are we saving information about? Because key is okay, I'll do it like this. If they say put, so what are you going to tell me about? And let's say string key equals sc.next line. All right, so we'll do it like that. So if the person types in the command put, we'll ask them, what are you going to tell me about? We'll read a line of input, store that in key, and then we'll pass that to the save info method. So it will ask for information on that particular thing, and it'll store it in this hash called data. And if we say get, we'll just come down here and it will it'll ask what we want to know about. Okay, so let's put some information. So what are we going to tell them about? Let's tell them about a laptop. Okay, tell me some things about a laptop. Expensive. They are useful. They break often. I like them. Alright, and then I'm just going to hit an enter on an empty line, and that takes me out of my loop, and now the system should know about a laptop. So if I say get, tell me something you want to know about, and I say laptop, oh, doesn't know anything about a laptop. Fail, I don't know anything about get. Yeah, I had a feeling. Alright, so let me do this. Alright, what are you going to tell me about? Okay, so if you say get, what do you want to know about? And we'll get a keyword from them. Let's say item equals SC, and now we'll ask for information about item. So when I was working on the lecture today, I was going to do something with syllables and words, and then as I started lecturing 44 minutes ago, I decided that was going to be really boring, so I switched it, and so I haven't thought this through very carefully, but we'll get there really quickly. So show info is going to take a key that we want to know information about, and so we will get information on that and go through the linked list. Alright, so let's put information on a laptop, large, heavy, kind of cool, with typos. Okay, so now if we say get information on a laptop, and it tells me the things it knows about a laptop. Okay, so let's put information on, what are you going to tell me about? Plants. Okay, so tell me some things about plants. They are green, they like sunlight, you need to water them, they don't bite. And there's an empty line, and let's talk about dogs. So what do we say about dogs? They like to play fetch, they eat a lot, and they are furry sometimes. Alright, so now we can say get me information about plants, and it tells me I know 4 things about plants, and there's the 4 things it knows, right? And so the point is these strings are stored in a linked list, right? And that linked list is in the hash map, and it's associated with the key plants. And if I say get information about a dog, right, same thing. And if I say get information about a cat, it says I don't know anything about cat. And if I put large dogs, you can tell it's something about large dogs. They think they're small, they like sitting on you, they eat more than small dogs. Alright, so I can still retrieve information about get dog, and I can say get large dogs, right? And so my key in this case, you know, is not just a word, it's a string, right, that contains spaces. That's not a problem. Just like these strings contain spaces. Makes no difference, right? And this is way beyond what you could do with just a plain old array, right? You could have an array of strings and you could search it for a string like this, and then, you know, associated with that, maybe you could have an array of strings like this. But this is very direct, right? And if I wanted to go back and insert things in here or add things to this, I could have commands for doing that as well. Right now, if I say put, so let's say get laptop. Okay, so if I say put laptop, and I only say one thing about it, so I can say get laptop, right? I've overwritten that thing that was in my hash. Okay. Now what I could do is when you say put, information about a laptop, before I go ahead and I create a new linked list, I could check my hash to see if a laptop's already in there. And if it is, then I could simply append to the end of the linked list. Right? So instead of making a new linked list, I would start with the linked list that I get when I say, hashmap.get, parentheses, laptop. And then I would, when I add to my linked list, it would just append to the end. Then you got PA2, right? This with integers instead of strings and with appending to the end, that's basically PA2. All right, so I will post this code up on Canvas, and I'll probably do a similar example in the afternoon section, but now I know what I actually want this program to do, so the development of it will probably be a little smoother. But anyway, that's hopefully helpful in some way. Could you have small dogs, large dogs inherent from the dog entry? You could make something to do that, but no, not directly. These are really just strings of data. So we can't really leverage the idea of inheritance and extension yet from Java classes. Are there any convenient ways to traverse the hash map? Yes, we need to talk about those, but it's something called an iterator. And I'll put that on my list for Monday to talk about iterators. But it basically lets you say, give me each key from my hash one at a time. Each time you call this method, it will give you another key from your hash, and then you can use that to retrieve the corresponding data. All right, I will leave it there for now. Open Lab tomorrow. Come in with code samples. We can work on it together. I will see you next time. Have a good afternoon.